give a quick overview of the latest architectural changes in API management platform at Qantas. I'm Waleed Ahmed, I'm principal engineer at Qantas IT. Little introduction about Qantas. Qantas is a pioneer in the aviation industry for over a century now. We are globally recognized for our focus on reliability, safety, and operational excellence, as well as innovation in all aspects of our work. If you may not know, the escape raft, the inflatable escape rafts in all the aircraft now was invented by one of the engineers at Qantas in 1965. And continuing our innovation journey, we are redefining the ultra long haul travel using our introduction of Airbus A350 from reducing the travel time as well as increasing the customer experience on our aircrafts. Few notes about myself. As Joy introduced myself, I have been Qantas for over 4 years now. I'm proud to be technical leading the platform, defining its architecture and the development and day-to-day operations of the platform. A bit of an overview of API management platform at Qantas. Introduced in 2018 using WSO API management product and key manager. It is a cloud-based deployment. Since its introduction, it has been integrated or used in so many different business units and sub-organization in the platform, in the organization, ranging from booking and reservations applications to flight operations, engineering systems, loyalty programs. And the main focus for the platform is to adopt our core values of safety, innovation, and reliability. And since the introduction of the platform in 2018, we have done multiple successful upgrades and migration projects to evolve the platform, adopt the new features introduced in WSO products. And this session was mainly to highlight the key architectural changes in the platform that evolved it from somewhat complex state to a more agile and resilient state. So the key changes that we are going to talk about today is about the adoption of Event Hub architecture in WSO API management product, how we used the WSO-based images for container-based deployments of the platform, how we enhanced the observability, logging, and logging capabilities within the platform, and also how we extended our support for open standards in all the APIs onboarded to the platform. So let us go through prior to the state of the platform, prior to the upgrade to WSO API management version 4. Since its introduction, it was cloud-based deployment using codified infrastructure, and it was utilizing the distributed architecture of WSO. However, the deployment was database-centric. As you can see, almost all the components were connected to the centralized database. We were heavily reliant on disk storage for some state sharing between the data plane and the control plane. We were also relying on custom plugins and something like WSO Analytics product, which no longer exists. as well as a business process manager of WSO. Although the platform was performant, but the number of components were large, we have challenges into making all the components highly available. And because of the dependency on the database, we were having some restrictions on scaling up the data plane to cope with the increased or changing traffic needs. However, with the upgrade to 4.1, we thought of it is a very good chance to make use of the Event Hub architecture and built-in WSO API manager since version 3, if I remember correctly. Event Hub architecture is based on also on open standards. It is AMBQ, standard internal APIs, calls, and some binary traffic that we can audit and troubleshoot. And the beauty of this architecture that we are able to eliminate all the needs to have any disk space or sharing between the data plane and the control plane. And this not only helped us to have an agile and stateless platform, but also to be able to extend the deployments of the data plane into different areas, like embedding the data plane or new data plane sets into service mesh without almost any change in the deployment configuration or the API landscape definitions. One key advantage of the Event Hub architecture is that the data plane no longer depends on the database altogether. So we can scale up the data plane as per the business needs without fearing that we may get into a problem because of the increase in the number of connections, we have an incident in the database that the database was almost fully unoperational, but almost 70 or 80% of the traffic on the production was running without almost any issue till the database was restored. So this new platform architecture allowed us not only to get off the hard dependency of disk and database-centric deployments, but also to implement high availability on all the components. All the components in the platform are now highly available. We don't have any restriction on the deployments of the gateways, making it very loosely coupled to deploy the gateways into new deployment patterns. And one of the most important things that we have truly consistent state shared between the data plane and the control plane, which is one of the most tricky problems. If it happens that the control plane sees the API artifacts or tokens or subscriptions in a way different from the data plane. When some issues like this happen, it is very, very hard to troubleshoot and find out the root cause of the problem. We'll talk about the ALK logger in next slides. The next major change that we have adopted was using WSO-based images. In the legacy platform, we were using bare metal deployments and in-place upgrades for the product, which was not fully aligned with our immutable infrastructure strategy. But with the adoption of WSO-based images, we are able to just deploy new image from WSO repository, and the upgrade is just done using this approach. This approach not only allowed us to make the maintainability easier, but also allowed us to focus our efforts into hardening the base images that we are using in the platform, according to the group security and best practices across the organization. This is shifted the team efforts towards left during the build time, but also from deployment point of view, we were able to deploy the platform on bare minimal operating system. There's almost nothing deployed on the virtual machines except Docker. And this allowed us to have different sidecars running side by side with the platform for security scanning and vulnerability detections, which this overall approach improved the security posture of the platform and reduced the effort and cost of maintainability to a great extent. The next topic that we're going to explore is the enhancements that we did for observability and logging. We'll talk first about the observability. WSO is deployed on standard Java runtime. So we were able to utilize standard Java instrumentation to inspect all components of the platform. This not only allowed us to have deep visibility on the API traffic in general, but also on how the platform is behaving. We are able to monitor and view even the SQL statements that the platform or the product is executing against the database and detect whether there's something odd or there is any performance bottleneck happening because of this. This also allowed the API developers or the backend engineers to troubleshoot issues and find out trending errors or any kind of differences in the API traffic and give us real proactive and early detection of errors in a safe way that we can share with almost all the tenants in the platform. The next change was, as I mentioned earlier, we were dependent on WSO analytics product in the legacy platform, but during the upgrade, we were not able to use the WSO SaaS product because of data residency regulations in Australia. So, but we were able to use the WSO out-of-the-box Elastic Stack logger exporter, which allowed us to ship the sanitized API traffic to our centralized logging system. This not only allowed API management team to troubleshoot and find out issues, if any, when they happen, but we are able to share these sanitized logs with API developers team in a safe way that we are 100% sure that there are no sensitive data ever logged by these into these logs. Continuing our focus on using only open standards or standard features in general in API management platform, since this platform, we were using standard Open API standard definitions for API lifecycle management, but it was limited only to REST APIs. However, during the upgrade and after the upgrade as well, with just utilizing WSO product APIs, we were able to build a unified API lifecycle management interface that not only allows the adoption of different types of APIs into the platform, but also to embed our governance and control logic into all the API onboarded to the platform from the very early days of API development. This shifted the developers' effort left as well, allowed everyone to adopt it to even a standard naming standard for the APIs, for the API resources, for the versioning of the APIs, and also to add controls on how the APIs should be exposed either externally or internally. We have tool gates implemented into the management interface. For example, if someone is trying to deploy an API to the internet for the very first time, we block this exposure of the API to the internet till we are sure that the security assessment process has been implemented. At the moment, with the unified interface, just using standard API definitions, OpenAPI 3, and Swaggers, GraphQL, and even legacy technologies like SOUP over XML. All these types of APIs are just managed by a unified interface with standard API metadata that we defined using our DSL. And most recently, we have onboarded the API product feature of WSO, but however, we are rebranded it as API bundles, and we sort of using this feature to rediscover existing APIs for new consumption patterns. For example, if you have an existing internal API that has many resources and you want to expose few of them to an internet-facing client, using API bundles, you can just grab few of these resources from one API or many APIs, rebundle them into a new endpoint, and expose them as if this is a new API, keeping the existing back-end development almost the same without any change. There are key outcomes from these changes in the architecture. The main one from them is the loose coupling. We have to accept failures. So any platform or any shared platform will have failures at any point of time, but the balance is to find out where should the platform get an outage versus that, yes, it can work with degraded performance or degraded features. Something like Event Hub allowed us to have this loose coupling, as well as much more simplified deployments for all the components. We were talking about 11 or 12 components in the legacy platform. Now we are running 4 logical components. Yeah, definitely we have lots of segregation. In the data plane, we have different data planes per business unit or subgroup. And this allowed us also to be able to scale up as we go, based on the changes in the traffic pattern. And something like the adoption of standards and as well as standard features give us the opportunity to have a consistent and steady adoption of the platform across the organization. This is mainly, and this is not only helping the API management team, but also helping WSO support colleague. When an issue happens, we almost don't have any customization implemented in the platform, which allows us to just find out the issue, if any, as much as possible. We can just point out where is the issue is happening in the product. And the enhancement in our logging and observability allowed us to see and early detect issues even prior to having some other external party detect these issues, which give a very good trust model between not only the technical community within the organization, but also within the business stakeholders. Overall, what we are able to achieve is really highly resilient platform that can withstand issues in different components or even in its main database. Yes, it can. Anything can fail, but we are able to recover and to isolate issues in more streamlined approach. With this reliability and resiliency, we are able to build communities around the platform, which is the most important achievement that we are able to get from having its trustworthy platform. So rather than just being a utility or shared infrastructure component within the organization, we have a community of developers, API consumers, even business stakeholders that they share a common vision about the platform, that they can share ideas, prioritize their requirements, and we already have a large set of supported channels, optimizations, and feature requests, prioritization, and it is not coming from API management team, but from the tenants of the platform. And I think this was a good achievement, especially in the past 2 years, where we have almost very minimal number of critical incidents for the platform, and definitely zero outage throughout these years. So thank you for listening to these changes in the platform. Happy to take questions, or we can connect afterwards.